Okay, so question 1 wants you to find the area and circumference of a circle. So area is pi r squared. Type it here, I guess. Right, area equals pi times the radius squared. Okay, so we're going to substitute in 12 for our radius. So area equals pi (12). Let's just write it. It's going to be a little messier because I'm on my PC, but that's okay. My area is pi r squared. And so you're substituting in 12 for your radius. So that's going to be 144 pi. And then what units would be inches squared because it's two-dimensional. Okay, circumference is 2 pi r. So 2 times pi times 12. That's going to be 24 pi. And the units there will be inches because circumference is just one-dimensional. It just has a length, whereas area has a width and a length. Off to the other screen. Okay, number 2. Let me clear. Okay, find the circumference of the circle. So they're giving us area. We have to use the area to find the radius, and then we can use that radius to solve for the circumference. So we're going to have to use both the area and the circumference formulas here. So area is 16 pi. So 16 pi equals pi r squared. We divide both sides by pi, and we get 16 equals r squared. Then we square root both sides to get rid of the square, and we get r equals 4. Then we can take this and put it in. C equals 2 times pi times 4. And that's going to be 8 pi inches. Okay, so you use the area formula to solve for the radius because they're giving you the area, and then you plug the radius into the circumference formula to find the circumference. On the next one, they're giving us the circumference, and they want us to find the area. So we're going to use the circumference to find the radius this time. So 22 pi equals 2 pi r. Divide both sides by 2 pi. That's going to be 11 equals the radius. And then we can substitute that into our area formula, which is pi r squared. So area equals pi times 11 squared, which is 121. So 121 pi inches squared would be our area. Number 4 is arc measure. So we know they're telling us here the measure of arc DB is 60, and they're telling us the measure of arc CE is 90. So we have to use the semicircles to find the other missing arcs. So the measure of this arc here is 180 because that's half a circle. So we do 180 minus 90. And that's going to give us 90 for our EB. And then we have another half circle on the other side. So arc CDB is a semicircle. It adds up to 180. So we do 180 minus 60 is 120. So the measure of arc CD then is going to be 120. Once we have all the minor arcs, we can simply fill in our missing pieces here. So DC is 120. BCE, we start with B, we go through C to E. That's 60 plus 120 plus 90. That's 180 plus 90 is 270. DE, it's a minor arc DE, so it's a short way around. So 60 plus 90 is 150. And then E through B all the way around to C is 90 plus 60 plus 120 is 270. Okay. Number 5. So the measure of arc AC there is 120, right? The measure of the central angle is equal to the measure of the arc, so we have 120. And then we know a circle is 360 degrees. So we can do 360 minus 120 is 240. So we know the measure of arc ADC there is 240 degrees. Okay, and then we can use the arc length formula to find, so that's the measures of the arc. They're 120 degrees and 240 degrees. Now we can use our arc length formula to solve for the lengths of the arcs. So arc length is x over 360 times 2 pi r. So we're solving for arc length. We have the measure of the arc. The red one there is 120. Times 2 times pi, and then the radius is 24. Okay, you can go ahead and put that in your calculator if you want, but if you want to reduce it manually, we're going to have 1/3. Right, 120 over 360 is 1/3 times 2 times 48 is, or 2 times 24 is 48. And then 1/3 of 48 is going to be 16 pi. And they don't have units for us, so we'll just say units. Measure of the green arc there is 240, so we're going to do arc length equals x over 360 times 2 pi r. So the measure of this arc is 240 over 360 times 2 times pi. The radius is 24. So again, you can just go ahead and put that straight in your calculator, but if you want to reduce it here, that's going to be 2/3 times 48 pi. And then 2/3 of 48 is going to be 32. So this is going to be 32 pi units. Okay, we noticed too how the measure of the two arcs, 120 and 240, add up to 360. And the measure of the two lengths add up to the circumference, which is 48 pi. Number 6 has to do with find the area of the shaded and the unshaded region. So the measure of the arc on the shaded region is 135 degrees. So sector area is equal to x over 360 times pi r squared. So that's going to be sector area equals 135 over 360 times pi times 9 squared. Okay, so that's going to be sector area. So from right here, you can just put this in the calculator if you want. 135 over 360 is 3/8. You can put, what is it? 70s. 45. 45 would go in 3 times. 135 and 45 goes into 360 8 times. Okay, and then the 81 pi would be your area. So we want 3/8 of 81 pi. Let's see, that's 243/8. So again, you can put in the calculator, get a decimal, that's fine. I'm gonna leave it as a fraction though. So 243/8. Just to double check, let me make sure I didn't screw anything up. Nope, we're good. Okay. So that's the shaded region, right? That's the area of the shaded region right here. Okay, now we need the area of the unshaded region. So we're gonna have to find the measure of the arc. So again, measure over the whole circle is 360. So if we do 360 minus 135, we're gonna get 225. So we know the measure of this arc is 225 degrees. So 225 over 360 times pi times 9 squared, right? And that would be our sector area. So sector area, x over 360 pi r squared. Right, so that's gonna be, this was 3/8, this should be 5/8, right? So 45 goes into 225 5 times, and it goes into 368 times. Sector area here. That's gonna be 5/8 times 81 pi. And then 80 times 5 is 405, right? Plus 5, so 405/8. Does not look like it can be reduced. So it looks like that's gonna be our answers. And then this should be meters squared. This should be meters squared, because again, area is 2-dimensional. So let's just verify that this is right. 405 divided by 8 times pi. Okay, and you certainly could have gotten a decimal and rounded that as well to 3 decimal places. Okay, but again, if notice if we added these together, it should be equal to 81 pi. So that would be 648 divided by 8. $64, 81 pi. Yep. So they should add up to the total area, which is 81 pi. All right, number 7. Okay, find the radius of a circle that has a sector area of 9 pi meters squared and whose central angle is 90 degrees. So we're using sector area. So sector area equals x over 360 times pi r squared. Okay, sector area is 9 pi, so we're going to substitute in 9 pi for our sector area. The central angle is 90 degrees. And then we are solving for our radius. So if we want a diagram to visualize it, we have a 90-degree arc. 90 degrees. The area of the sector is 9 pi. And we are looking for the radius. So all this in here is 9 pi meters squared. We're looking for the radius. Okay, we can divide pi on both sides right away. And we get 9 over 360 times r squared. Okay, there's 2 ways to do this. The easiest way is to reduce. So 9 equals 1 over 4 times r squared. And then multiply both sides by 4. So you get 36 equals r squared. And you take the square root of both sides and you get 6 equals the radius. Okay, sometimes it's harder to reduce the fraction, and I know a lot of you guys struggle at reducing fractions. So the other way to do this would be to simply multiply by 360 on both sides. Okay, that cancels with that. We left with, so 360 times 10 is 3,600. So 3,600 minus 360 is going to be 3,240. 90 r squared. Okay, and then we can divide both sides by 90. And that's going to give us 36 equals r squared. And then you can take the square root of both sides and you get 6 equals r. So 6 meters. All right, so you can either reduce the fraction first and then multiply by whatever, or we can just straight up go times 360 on both sides and then divide by 90 on both sides. All right, the next one, it's very similar, except we have the arc length instead of the sector area. So our arc length formula is x over 360. Arc length is equal x over 360 times 2 pi r. So arc length is 9 pi units, or 9 pi meters. The measure of the central angle again is 90. And then circumference is 2 pi r, and r is what we're solving for. So I'm going to divide by pi on both sides, cancel them out. Okay, and then I'm going to simplify this side. So I'm going to have 9 equals, that is 180 over 360. Right, 90 times 2 is 180. Okay, and we're left in the same dilemma as last time. We can multiply both sides by 360, and then divide both sides by 180. That'll work. Or we can simply reduce. We get 9 equals 1/2 times r. And then we can just multiply both sides by 2. And we get 18 equals the radius. So that would be 18 meters. And the last one, number 9, find the area of the shaded region. So we need to find the area of the sector. Right, the area of the sector would be all of this. And then what we're going to do is we're going to subtract the area of the triangle to get the area of that blue region there. Okay, so sector area is x over 360 times pi r squared. So sector area is 90 over 360 times pi times 8 squared. Have sector area equals, that's 1/4. And then 8 squared is 64 pi. And you can simply put it in your calculator at this point at the second step there. And then 1/4 of 64 is going to be 16 pi centimeters squared. Okay, so that's the area of that entire sector. We need to then subtract the area of the triangle. So the area formula for a triangle is 1/2 the base times the height. Okay, the base here is 8. That's also the radius. That means the height is also going to be 8 because that's also a radius. So we have a base of 8 and a height of 8. Because those are the radius. They're both radiuses, so they're both have the same length. Okay, 8 times 8 is 64, times 1/2 is 32. And that's again centimeters squared. So that's just the area of the white triangle part there. So when we take 16 pi here and subtract 32, that's going to give us our answer. So we're going to take 16 pi, which is all of this area. We're going to subtract the area of the triangle, and that's going to give us the area of the shaded region. So 16 pi is about 50.3. Right, so if we want to round to the nearest tenth, that's going to be 50.3 minus 32. And that's going to be 18.3 centimeters squared. put in 18.3. Okay, and if you can do everything on here, you should be able to easily ace the test.